This define a function. Is each x I put in here give me a y? Well, wait a minute. I know that x cannot equal -2 because that would make this 0. It would not give a real number answer. But every x I put in here, I could divide in 3. Yeah, this could be a function. This could be a function. And the domain, since x cannot equal -2, the domain in interval notation is from -infinity to -2 with parentheses union -2 to infinity. We'll give things in interval notation. Now, the range, the y values. Believe it or not, the y values is not all real numbers because of this 3 up here. There is no way that y can equal 0 because the only way a fraction equals 0 is if the numerator is 0, and it's not, it's a 3. So the range is from -infinity to 0 union with 0 to infinity, and those have parentheses because 0 does not work. To use when we're talking about functions, we use function notation. A function f is defined by a rule or an equation using x and y for the independent and dependent variables. We say y is a function of x because we start with x. It's the independent variable. We can pick anything in the domain for x, and that gives us a y. That means that the y depends on what x we use. We use the notation y equals f of x. This is called function notation. Express this, we read it, f of x. The letter f is a name given to this function. If we had y equals 9x minus 5, we can call it a function f and say f of x equals 9x minus 5. Notice I just put f of x in place of y. So f of x is just another name for the dependent variable y. If we said y equals f of x equals 9x minus 5, like on the last slide, and then we said x is 2, then we can find y, or f of 2, by replacing x with 2. So f of 2 is 9 times 2 minus 5, 13. The statement if f equals 2, then y equals 13 represents an ordered pair, 2, -13, and is abbreviated with function notation. F of 2 is 13. Now, we've had a couple definitions for functions already. We'll emphasize a couple more. A function is a relation in which for every distinct value of the first component of the ordered pairs, there's exactly one value for the second component. Or we could say a function is a set of ordered pairs in which no first component is repeated. Or we could say a function is a rule or corresponds and assigns exactly one range value to each distinct domain value. All true for functions. One thing we have to get straight is the symbol f of x does not mean f times x, but represents the y value for an indicative variable. Just as f of 2 is the y value that corresponds with the x value 2. So remember, f of x does not mean multiply. Now we want to evaluate this. We've got f of x equals -x squared minus 6x plus 4, and g of x is 3x plus 1. We're going to find and simplify. Well, f of -3. Well, that's what we do is to find that we use the function as defined and substitute -3 in place of the x. Now notice this first negative up here is negative, and then it's x squared. So it's negative, and then the -3 squared minus 6 times -3 plus 4. Well, -3 squared would be 9, so -9, -3 times -3 plus 18 plus 4, so 9 plus 4 or f of negative 3 equals 13. In your notes, make sure you show the steps for that. For this one, we're finding f of r. So what we're doing is we're taking that f of x function, and wherever there's an x, we're putting an r. So it becomes negative r squared minus 6r plus 4. Now this one we want to actually find a g of something. We hadn't done that yet. So g of x is 3x plus 1. So in place of the x, in this case, I'm finding g of r plus 2. I'll put an r plus 2. So this equals 3 times r plus 2 plus 1. So we found it, and then it does say to simplify. So we would have 3r plus 6 plus 1, or 3r plus 7. Now we need to talk about the average rate of change from 2 points. From here's x1, y1, and x2, y2. There's our average rate of change if we had 2 ordered pairs of the function. Notice this function doesn't curves, it doesn't go straight, but we could we'll find an average rate of change by just taking the rate of change from 2 points. And the y coordinates, wait a minute, change in y over change in x. Y sub 2 minus y sub 1 x sub 2. It's really, look, we're just finding the slope of the line between those 2 points. If we happen to define those 2 points as x, and the y value is f of x, which would be true, and here's x plus h, and the y value is f of x plus h, as it would be. Then we have what's called the difference quotient, and it's really just the average rate of change, because this is the y values, the second y value minus the first y value, and if we had the second y value, or second x value, minus the first x value, we would just get h. So really, when we're finding the difference quotient for the expression, we're finding the average rate of change, or the slope of the line we would draw between those 2 points. This is the difference quotient is very important, as those of you going on to calculus. So now we want to use that difference quotient. We're finding f of x plus h minus f of x over h. So here's my f of x. So I will have f of x plus h will be 1/2 of x plus h, and then remember it's minus f of x, so minus the regular function 1/2 of x, and it's all over h. If I multiply that out, I'll have 1/2 x plus 1/2 h minus 1/2 x all over h. Combining like terms, 1/2 x minus 1/2 x, that's gone. So I have 1/2 h over h, and the h's cancel out. It's just 1/2.